Hi, I'm Mr. Huber, and in this video we're going to talk about graphs of logarithms and the change of base rule. Look, let's start with two exponential functions. Well, 2 to the x, like this, domain is r, range is r plus. F of x is e to the x, well, e is approximately equal to 2.72, and it's as important as pi. It's just an approximate value. Well, both graphs look more or less the same qualitatively. If you drew them quantitatively, they would certainly differ. But well, they do have the same domain and the same range. Now, the inverse functions for these two are log to the base of 2, and here log to the base of e, or just written ln. Again, qualitatively, they look the same. But now the domain is r plus and r, the range, and here the domain r plus and the range is r. Look, the domain, well, it's only defined for all the numbers greater than 0, so from 0 to plus infinity, 0 not included. So function, inverse function. We are talking about the logarithm functions. So what is the connection between these two? Look, you could write your log to the base of 2 of x like ln of x over ln of 2. That's the change of base rule. So log to the base of 2 of x is ln x over ln 2, or log x over log 2. This is now the logarithm to the base of 10, or even the log to the base of 4 of x over log to the base of 4 of 2. So you could use this change of base rule, or even log to the base of a certain a of x divided by log to the base of a of 2. So it doesn't matter. That's how you change the base. But now what does that mean? When you can, if you can write this like this, you can write it like this: 1 over ln of 2 times ln of x. So you see, this function is just a multiple times the ln function. So you could write every logarithm function as something times ln. Well, that something in this case is approximately 1.44. So that means the logarithm to the base of 2 function is just a vertical stretch. Now look at this. The green one is the ln function. And a vertical stretch means that everything is stretched apart vertically. So you see, well, you can't see it over here, but you can clearly see here, everything is stretched apart, so it goes higher up. But well, qualitatively speaking, these are more or less the same functions. But well, when drawn quantitatively, you can see the differences. And again, look, the log to the base of 2 of x is nothing but 1.44 times ln of x. So now, just one other thing I would like to talk about. Look, we talked about this already. If you want to solve something like this, you could use the log to the base of 3 of x, or just the function. Well, then you get x is log to the base of 3 of 7. Well, we have this key on this calculator. That's 1.77 approximately. 1.77. But well, you could have said, well, I don't have that key on my calculator. Like, for example, this calculator. It does not have such a key. It's only got the ln key. But you're not stuck, because you can always write this as ln 7 over ln 3 by using the change of base rule. So now you could type this in here, ln 7 divided by ln 3. And you see, again, you get the exact same thing, 1.77 approximately. Well, once you're here, you can use the change of base rule, but you can do it more naturally. You could say, well, 3 to the x is equal to 7. Just apply the ln on both sides, and then you get ln of 3 to the x is equal to ln 7. Now you use the rule log of x to the p is p times log of x. So you take out the x, ln 3 is ln 7. Now you divide by ln 3 and you get x is ln 7 over ln 3, which is again the same thing. So as a quick recap, every logarithm function is in fact nothing but a number multiplied by the ln function, or the ln function multiplied by a number. Okay, the ln function multiplied by a number. Every logarithm to every base can be written as the ln function. And, well, when you're stuck at something like this, you don't have that very special key on your calculator, well, then you're not stuck, because you could use the change of base rule and use whichever logarithm key you have. Well, you at least need one, either the log to the base of 10 or the ln key, or whichever key you want, okay? Or you could do it more naturally and just use the natural logarithm. Or you could even use the log to the base of 10. Well then, again, same thing. You again use the same rule here, x log 3, log 7, and then log 7 divided by log 3. And if you type this in, let's just do it, log 7 divided by log 3. Here we go, again, the same thing. Hope it wasn't too difficult. See you in the next one.